An electrostatic motor is a type of electric motor based on the attraction and repulsion of electric charges. I am going to demonstrate a type of electrostatic motor, and I need a high DC voltage source, and I'm going to use this Vandergraft generator I constructed. I will explain how to construct this generator and how it operates in a subsequent video. I just needed a voltage source on the order of 10,000 volts, and that's what this can will charge up to. I am going to demonstrate an electrostatic motor that is referred to as Franklin's bells because Benjamin Franklin developed it. Since Purdue has a School of Agriculture, I'm going to use two cowbells here, but suspended between them will be this Liberty-shaped bell, and it's suspended on a string, so it's isolated electrically. And I'm going to now connect, or I have connected, the right cowbell to the Vandergraft generator, so it will charge up to 10,000 volts, and the left cowbell is grounded. I'll now start the Vandergraft generator, and you'll hear the little electric motor in it turning. So I'm going to give the little suspended Liberty bell a little nudge. Now I'll disconnect the Vandergraft generator, turn it off. I'll restart it. Here's an illustration of Franklin's bells. So this line here will represent the cowbell on the right, which is connected to the positive high voltage, so it will charge up positively. This line here represents the cowbell on the left, which is grounded, so it will charge up negatively. So you can think of this as if it were a capacitor. And electric field lines will then begin on the positive charges and terminate on the negative charges. Now let's put a conductor in the middle, and I'm going to choose a nice spherical conductor for illustrative purposes. So what will happen then is the electrons in the conductor will be attracted to the positive charges on the right cowbell, and so it will become negatively charged, and the left-hand side will become positively charged. The conductor is still net neutral, and our electric field lines now will begin on positive charges, terminate on negative charges as shown. Now, if everything's symmetric, the conductor is equally attracted to the two cowbells. But if our conductor is a little off-centered, or if I give it a little push, say to the right, then it will be more strongly attracted to the cowbell on the right. Let's just focus on the attraction of the conductor to the right cowbell. So at this point, the negative charges on the inner conductor are closer to the positively charged cowbell than the positive charge here, so there will be a net attraction. So the conductor will swing until it hits the cowbell on the right. At that point, it will become charged positively. This electrons on this inner conductor will flow off onto and spread around the large cowbell, and so the conductor will become net positive and then thereby be repelled by the cowbell on the right. And it will also be attracted to the negatively charged cowbell on the left. And when it hits the cowbell on the left, the same thing will happen. It will become negatively charged now and be repelled by the cowbell on the left and attracted by the cowbell on the right until it again hits the cowbell on the right. The electrons will flow off, spread around the cowbell, and the conductor will become positively charged and again repelled and attracted by the cowbell on the other side. And this process will just continue.